Good morning, everybody. Hope everybody's doing well out there. Continuing with our series on basic Pygame programming, I'm going to go ahead and start by making a cool math video. So one of the things I wanted to cover in this video is 2D Cartesian coordinates and kind of explain what's going on with the computer screen, why it's a little bit different from drawing an X and Y axis on your say like some graph paper in a math class or something like that. It's the same basic concept, but in computers it's reversed. The y-axis is flipped. The x-axis stays the same, so it's a little confusing at first, but hopefully we can demystify that in this video. All right, so we're gonna go ahead and get started by importing Pygame. Alright, and so keeping in line with our objective, we're going to go ahead and keep things object oriented. Define init. Self dot. Actually, first before we do anything else, let's go ahead and initiate Pygame. And then self dot dimensions is equal to, we'll call it sdim. Sdim is the variable that I came up with for screen dimension. So we're going to make an array. I'm going to go ahead and create an 800 by 600 screen. Alright, so let's go ahead and create the screen. Self dot screen is equal to Pygame dot display dot set mode. Alright, and then we're just going to go self dot sdim right there, and it'll take it like that. Alright, next we're going to need self dot run. That's going to be for our main game loop, or our main loop for the program, and we're going to make that equal to true. And then self dot FPS is going to be equal to, we'll go ahead and make it 15 here because I want things to go a little bit slower. Typically you'd use 60 for a game, 60 frames per second. That seems to be the standard that a lot of people have landed on. A lot of argument in forums back and forth, but we'll go ahead and use 15 for this one because we're just going to be making a graph. Alright, and so what else do we need? Oh, we need a timer for that. So self.timer is equal to pygame.time.clock. Alright. Okay, so I think that's all the variables we need to get started with getting a window on the screen. We're going to define our main loop. Import self, or include self in that. Okay, while self.run. Okay, so we're going to go self.screen.fill. Okay, and this is important because the reason why we want to make sure that we fill the entire screen is we want to kind of blank everything out. It's kind of like erasing the board before the next screen updates. If you don't do this, everything that you've drawn will just sit on the screen and it never goes away. And so this is kind of like our way of erasing it. Gray 3. Alright, so that's the color I'm going to use for that. Okay. Next thing we're going to do is we're going to regulate that time. So self.clock.tick, self.fps. Alright. Okay, so after we've got that handled, we're going to go ahead and go for event and pygame.event.get if event.type is equal to pygame.quit self.run is equal to false. That'll get us out of that game loop. Okay, so that should be everything we need for that event handler, and that's the only event we're going to be using in this program for this one. Alright, so once we've got our events handled, we want to go ahead and update the screen. Pygame.display.update. Alright, and of course, when we break out of that loop, we want to make sure we quit. Pygame.quit. Alright. Okay, so let me go ahead and pull up that. Go ahead and run it real quick. Okay, and something happened. Let's see. Run. Oh, okay. So I know what I keep making this mistake, and I did this in the last video. Forgot to call, since we're doing an object-oriented approach, forgot to call this. So we go to game dot game. I wasn't getting any errors, but the window wasn't coming up. It's because we're not actually calling it. So that's kind of an important piece of the pie. And we did get an error. It says we got an error on line 15. Game object has no attribute clock. Okay, and of course it doesn't. We have a timer is what we named it. Alright, let's go ahead and run it. It's thinking, and of course, okay, so we got a window. Alright, and you can see it's not quite dark jet black, but it is slightly darker than it is slightly lighter than the black screen over here. So that's our gray 3 that I chose to use. Alright, so let's go ahead and create a math object or a math-rect object. Okay, and so what we're going to do here is we're going to create a separate, I've set aside a separate class for just creating a simple like square, and this way we can instance it, and we don't have to rewrite that code several times. And what I'm going to do is I'm going to call it and store that math object that we're creating right here. I'm going to store that in a list, and then we'll be able to call that list and iterate that list and draw that onto the screen. So import Pygame class. Okay, we're going to call it math-rect. Keep doing that. Define init. Okay, and this is going to be real simple. So we're going to go self x, y, width, height, and we're going to go ahead and include the dimensions. I'm not going to use them just quite yet, but we'll include it because we will use it later. Okay, so we're going to create our main Pygame rectangle object. Remember in the last video it was Pygame.rect. Okay, and we're just going to go x, y, width. And of course we want to drop the screen, so we'll create a draw function, and it's going to be self screen and color for our color variable. Okay, so Pygame.draw.rect screen color, and then our rectangle that we created, self.mrect. Alright, and so that should be all we need to get that drawn on here. So let's go ahead and import it. So from math-rect import math-rect. Alright, and so I think it's a good idea right here to kind of explain what I just did there. So we're importing the file. It's in the same directory, so we can just import it directly like this. This file that we've created over here. And what this allows us to do is we're able to call this math-rect class. But if I didn't do it this way, okay, so if I don't do it this way, what will end up happening is let me go ahead and just show you. All right, so the way we'd have to do that, so we're going to create a math object, or math rect object. So we want to do import math rect. So we'll just import it like that, just the class. All right, and so let's go self.m. We'll call it m right now, and we want this object type to be a math rect type, but that's only going to get us the file imported. So we need to actually use that class in there. So we can do rect, and then add in our x, y. We'll go ahead and say it's 1 and 1, and 2 and 2, and then import our self.stem. All right, and so the reason why I don't want to do it that way is one, that makes the variable longer, or whenever we're working with it. So it kind of defeats the purpose on a lot of things. But also in right now it's not that big of a problem, but in the future, we may have a file that has several different classes in it, and we may not want to use all those classes, and so you only want to, it's just good practice, I think, and I feel like to just import what you need when you need it, and it'll make more sense. It makes sense to me. Do whatever works best for you when you're working on these projects. Okay, so now what we're going to do is we'll go self.m.draw, and then we'll put it's the screen, what were our variables that we passed through? I guess it was the screen and the color, and that's all we need. And so we'll just go with purple. For some reason I like just drawing it as a purple thing. So let's go ahead and run it and see what that looks like. And we should just have a tiny little purple square on the screen. All right. Oh, I keep making this mistake. It's self.screen. And if you do feel frustrated when you're programming, that you keep running into issues with errors when you go to compile or interpret your code. In the case of Python, it's an interpreted language, not compiled language. Just know that I've been doing this for a little bit longer than a day, and I run into a lot of issues where I'm just constantly troubleshooting issues. Okay, so game object. Oh, gotta save it. All right, and so we have right here it printed out to the screen, but it's real tiny. Let me go ahead and make that bigger, just so you can see it. Let's go ahead and make that. We'll do it 10 by 10. All right, here we go. So we've got a 10 by 10 square up in the corner, but you'll notice that it's all the way up in the top left corner, and it's not down in the bottom left corner like you would be expecting. And that's what I was talking about earlier with the y-axis being flipped. And so we're going to have to correct that. And so if we go back into math.mathRect, we'll go ahead and take that s dimension variable that we imported, and we'll take 1, and we're going to subtract our y value from that. Okay, and this should get us to where we want to be. Alright, and it's disappeared off the screen. Give me 1 second. Okay, so what I did was and I did real quick, kind of off screen, real quick, is I added, or I went ahead and moved it to 1010. I think what it is it's just showing up off screen. So yeah, go ahead and close that out. Let's go ahead and run it again and see what happens. All right, and there we go. Okay, so you can see now it's at the bottom left corner of the screen. And so now if we were to run draw a line in here, it'd be going in the right direction. All right, so with that said, let's go ahead and draw a line. And so what we're going to do here is I'm going to change self.m. We're going to change that to a list. And then I want to create a range, range is equal to, we'll go ahead and use 300 for now. We'll see if we like the way that looks. And if we don't like the way it looks, we can always adjust it later on. All right, so we're going to assign values. We're going to go ahead and append that list and assign values using a for loop. So for I in range self.range. Okay, all right, keep doing that. Okay, so self.m.append in Python. This is how you would add a value, an additional value to a list. So self.m.append, and we're going to go with math rect. Okay, we're going to use the I value, and then width. Let's go with 2, and self.stem. All right, so what this is going to do is going to go through, it's going to append this list 300 times, and it's going to add a value each time, a math rect object to each value. And so what we can do now is we can go ahead and call those values, and so we can iterate through that list. So for I in self.m, I.draw screen, and we'll go with our color is purple. Okay. Let me go ahead and make sure I delete this. Alright, go ahead and run it. Oh, looks like I didn't close something somewhere. Right here. Alright, save it and run it. Okay, and again with that, self.screen. Alright, and as you can see right here, we've got a line that's moving up. So each one of these points on this line is an individual Pygame rect object that we built. It's actually a math rect object that we built off of that, and so pretty straightforward. I think I'm going to continue on this one because I do want to show y'all how to do like an offset, do an XY axis. Let me see, what were our objectives again? So yeah, so we're going to draw the XY axis and instant rectangles for the graph. So we met 2 of our objectives. So in the next video, I'll go ahead and show you how to draw that X and Y axis, and then we'll show you how to do an offset on that. And then, doing this kind of stuff is what really helped me understand and get a good handle on not just like how to do things in Pygame or how to program and programming concepts, but also how to understanding how the pixels on the screen are interacting with each other. So hopefully you guys got something out of this. Thanks for watching.